Okay, so an application of the GCF factoring is factoring by grouping. And so what we're going to do here is we're going to show two examples where what we do is we group the terms into even sets. So the left-hand side will have 2, the right-hand side will have 2. And what we're going to do is we're going to factor out the GCF from each of those two groupings separately. So in the first one, we're going to group it like this. And what we're going to do is we're going to pull out the GCF from the orange part. And can we see that we can pull out a 3 as well as a p squared? And so what times 3 gives you the 24? It's going to be 8. And then what times p squared gives you p cubed? And that'll be just a single p again because the exponent is added. And then do it similarly, what times 3 gives you the 15? Which is 5. And then there's no more p squareds or p's at all. Now, just so if you haven't realized it yet, what we're really doing is distribution. So distribution and factoring are opposites of each other. So make sure you can do both, which is the distribution going forward and then factoring the other way going backwards. So the next one, what we can pull out from both of them is going to be a 7. And what times 7 gives you negative 56? So negative 8p, and then what times 7 gives you negative 35? Should be 5. Negative 5, sorry. Now, notice now that this is a problem like we did in the last video, where we want the two factors to be alike so that we can pull them out from both. But this one looks very similar to this one, but not quite. It's off by a factor of a -1. So what I need to do before I can bring this out to the front is take out the minus sign for the one on the left, or sorry, one on the right. So 3p squared, 8p plus 5. If I pull out a negative from both of them, it becomes -7, positive 8p plus 5. Now we have these in common. So we can pull it out to the front as a factor, and whatever is left over goes into the other factor. Sure. Now, you do need to check if this one is factorable or not, okay? But we don't have any tools right now to factor them, which we'll see later on. So just make sure that you understand when you get to this point, you actually have to check that one as well. So let's go ahead and do this problem. And I think you'll notice something very tricky here. So let's try to factor out something from the first two terms, which we're going to group together, and the second two terms here, which are also grouped together. And what we can do, because I don't know the factors offhand, is let's make a factor tree. So 56, 2, 28, 2, 14, 7, and 2. So 56 is really the multiplication or the product of all the tail branches, right, the bottom branches. Where 49 is just 7 and 7. So the only number that they have in common in their the tail branches is going to be the 7. So 7 is a factor of both of those. Can you also see that I can pull out an x, but no w and no k? So what times 7x gives you 56xw? So it's going to be 2, 4, 8 w plus 7k squared. And then do it again to the right-hand side. I'm going to factor out a negative right away because I know that I need it to be positive down here. But again, do a factor tree. 2, 12, 2, 6, 3, 2, 21 is 7 and 3. So in this case, the only thing they have in common is the 3, but I'm going to make it negative. I also have a y in common in both. So what times negative 3y gives you the negative 24? It's going to be 8w. Negative 3 times 7 gives you the 21. And then k squared. Okay, so they have the 8w plus 7k squared in common. So we can pull that onto the front. And whatever we didn't use, the leftover, will go into the second part of the factor. So 7x minus 3y. So what I don't want you to start doing is getting used to being in a mode where you always group the first two. So let's look at an example, which is 3x squared minus 8y plus 12x minus 2x. So let's try to group it the way we've been grouping it, which is by grouping the last two and the first two. So if we take out the GCF from the beginning, there's nothing there, it's just 1. So we have to leave it as 3x squared minus 8y. The second one though, I can pull out a 2 and an x. So we get 6 minus y. So after we went through the trouble of factoring out the GCF on the front and the GCF on the back, they don't have anything in common. So our grouping fails. Now that doesn't mean that you can't factor it by grouping, you just might have to rearrange the terms. So what I'm going to do is I'm going to group the parts with the y's together and the parts with just x's together. So let's rearrange this. And now let's try group it again as the back two and then the front two. So in the front, I can pull out a 3 and an x. And what is left over, what times this gives you that? X. What times 3x gives you 12x, so that's going to be plus 4. And here I can pull out a negative 2 and a y, which will give you x plus 4. So now they have something in common, which is going to be the x plus 4. I can write that in the front, and in the back, we just leave whatever was left over. So this is factorable by grouping, even though the original one we tried up here did not work. So be very careful. You have to try all the different combinations before you can actually include that you can factor it by grouping.